Parallel circuit explanation. Unlike a series circuit, a parallel circuit provides electrons with more than one pathway to flow. As you can see in this model, we have the battery and two light bulbs, and these ones are connected in parallel. As you see the wire here, there's a junction point where the electrons can choose to travel through this light bulb or through this light bulb. Connecting the circuit, we can see this happen. Again, we have a battery that is 9 volts, and we have two lights that offer 10 ohms of resistance. In this case, if we break the circuit, let's say at this juncture, we notice that the current can continue through the other path, allowing the light to stay lit, unlike a series circuit. We bring that wire back, it resumes there. Notice the brightness of the light did not change. Let's take a look at the current. If we take our ammeter, we'll notice that coming out of here, see this guy here, we'll notice that the current leaving here is 1.8 amps. The current coming back is also 1.8 amps. Through here, we'll notice that it's 0.9 amps, and here 0.9 amps as well. So notice the current splits of 1.8 splits evenly between the 0.9 and the 0.9, and it travels back. As it comes back through here, it's 0.9 and 0.9, and when it joins back together, it is again 1.8. Now if I change the resistance here, if I change the resistance of this light bulb, let's make that 20 ohms, roughly. Close enough. Actually, let's just see. Okay, there we go, 20 ohms. Then you'll notice that the current flowing through here is reduced. So again, we have 1.35 amps now, which has dropped because we have more resistance in the circuit. However, we notice that this is providing more of the current. We have 0.9 amps versus only 0.45 amps. And that's because the increased resistance makes it more difficult for the electrons to pass through here. Again, they come back together again at 1.35. If we increase this one also to 20, what we'll notice is that the current's slower everywhere. So 0.9 amps, because we've doubled the resistance. However, here it's still 0.45 and 0.45 again. Now, what does the law say? Let's take a look at our notes here. So a current in a parallel circuit. So it says Kirchhoff's law states that the sum of currents entering a junction equals the sum of the currents leaving the junction. And that's what I just pointed out. When we have 1.8 amps coming in, it might split into 0.9 and 0.9 amps. But when they come back together, they must be the 1.8 amps again. So if this was a particular case here, this current and this current and this current, I1, 2, and 3, must add up to the current through here, the I total. Now voltage, let's take a look at the voltage here. Let's go back and see what's going on. So in our diagram, if we grab our voltmeter, we know that across the battery, it was set to 9 volts. Now the battery voltage across these will also be 9 volts. The battery across any load in your system that's located in parallel will be the same. Therefore, this is 9 volts, and this is 9 volts as well. So if we look at Kirchhoff's laws, what it states here is that the voltage total will be V1 equal to V2 will be equal to V3. So if this is 9 volts, V1 will be 9 volts, V2 will be 9 volts, and V3 will also be 9 volts. Now resistance is a little bit more difficult to calculate. The total resistance of the circuit is calculated as follows. 1 over the total resistance is equal to 1 plus over R1 plus 1 over R2 plus 1 over R3. To find the total resistance in that parallel circuit, we have to add up the inverse of these and then take the inverse of it to find it in the end. So the key idea here is that as we add more paths, we're not actually slowing down the current. In fact, we'll get more current. Let's take a look at this in our diagram. So if I go back to this here, pull this away, what I'm going to do is just measure our current again. So our current was 0.9 amps. Now, if you remember back to series, if we added another light bulb in series, the current slowed down. However, if I take this and add another light bulb, you may be surprised to see that the current actually increases. So again, we notice that across here, right, for our voltage drop, it was 9 volts. Across here, it's 9 volts as well. We have the same voltage. Now remember the current before, and now we have more current flowing through here. So this 1.8 amps now flows through and gets divided in 3, giving us 0.45, 0.45, and this one here, we have actually more current running through there because we did not change this value. So if I change this, let me go back, change this to 20 ohms as well. There we are. Now we'll see that the current's the same. So the current's dropped 1.35. So if we've got 0.45 plus 0.45, that's 0.9, plus 0.45 again, there's your 1.35. But the key thing to remember is that the current flowing actually increases as we add more resistors or more loads when they added in parallel. And again, notice that the brightness of these light bulbs did not change when I added another light bulb. Again, contrast that with the series circuit.